Chapter 6, Lesson 2 of Advanced Algebra. We're going to continue our discussion of these higher degree polynomials that we've been looking at. Mostly working with the cubic functions in this lesson, but also a little bit with the quartics. We've talked about a polynomial in this form. This is called the linear factored form. These are factors of the polynomial because we'll multiply them together to create the polynomial in standard form, which we did in Lesson 1. We also looked at taking a polynomial, a cubic in particular, and factoring that when it has a common factor of x. And the reason we want to do that is the same reason that we did this factoring, or we used factoring when we were working with quadratics. And that is because if we know what the y value is, if we know the y value is 0, if we set this equal to 0, we know that by applying the zero product property that one of these three factors has to be 0. And so anything that makes either one of these three zeros is going to be what we call 0 of the function. So if we look at x minus 2, what number would we put in for x? In order to make this add up to 0, we would put in a positive 2. Basically, it's the opposite of what you see here. Also, we will look at this factor. What would make this one 0? Well, if we put in a negative 1 for x, that would make this one 0. And again, multiplying these together would give a product of 0. And then we would look at this third factor and see that negative 3, putting in that value for x would make this polynomial equal to 0. So these three values are called zeros of the function. Okay, they would make the function equal to 0. And the reason that that's so important is because if we think about the coordinate plane and we think about the x-axis, every single x of coordinate on the x-axis has a y value that is 0. If I go here to 1, the coordinate of this is 1, 0. The y value is a 0. If I that would be negative 1. If I go out here to 1, this would be 1, 0. If I go out here to, let's say, 4, it's 4, 0. Or down here to negative 7, 0. You'll notice that all of these y values are 0. So when the y value is 0, we're putting this in, what we're actually looking for is any x value that would make this 0 is actually the x coordinate where the y value is 0. So that's one reason why these are called the zeros of the function. So this actually gives me the coordinate 2, 0. This one gives me the coordinate negative 1, 0. And this gives me the coordinate negative 3, 0. So what these three values are actually are places where, if I graph these real quick, negative 1, 0, negative 3, 0, and positive 2, 0 are places where this function, if graphed, is going to cross or touch the x-axis. And so because it's a third degree, we haven't really looked at these yet, but you want to think about this or remember this, cubic functions are going to look like this very often. And we see that these are the places where it crosses or touches the x-axis. So you can see why having a polynomial in factored form is very valuable, especially if it's set equal to 0. It allows us to find three very important points on the graph, which allow us to get a quick picture of the graph, which is what we want to do. Okay, so these points are called zeros of the function. Now, these are also called, there's other names that you'll see used or hear used for these, and all of them mean the same thing. So one thing we know is that these are called the zeros of the function. These are all obviously also called the x-intercepts of the function because this is where the graph will cross or touch the x-axis. So you'll hear these points described as the x-intercepts as well. You'll also hear these numbers or these values called roots of the polynomial, and this is going to be an important word because even though these are zeros and x-intercepts, there are cases where it's not actually going to cross or touch the x-axis in the case of imaginary numbers, so we call them roots. So any of these three things that you hear all mean the same thing, so you should kind of be aware that that is actually three ways to talk about the same thing. Now, each one of these we've talked about already are called factors because we multiply them together. So linear factors help us determine what the zeros are. Now, you remember that if we know what the linear factors are, we can then multiply these together to get the polynomial in standard form. Okay, so make a note of that. We'll talk about that in just a minute. Okay, now let's talk about multiplicity. In other words, what if we have this x plus 1, let's say, squared? Now, remember, the squared is in front of the parentheses, so what this actually means is x plus 1 times x plus 1. And again, if this is equal to 0, what are the zeros of the function? Well, what would make this one 0? Negative 1. What would make this one 0? Well, negative 1. So negative 1 is used twice. So what we do in this case is we say that the 0 of the function is negative 1 because that will make this 0. And then we say that it has a multiplicity, and it has a multiplicity of 2, meaning it's used twice. So multiplicity just talks about the number of times that that 1 0 is used as a 0. And this multiplicity, you'll notice, matches the exponent. Okay, so the multiplicity matches the exponent of the linear factor. So let's say I had an equation or a polynomial x plus 3 to the 4th. All right, well, what makes this 0? The number negative 3. And what is the multiplicity of negative 3? Well, its multiplicity is 4 because negative 3 is actually used 4 times. Because if you think about this again, this is x plus 3 times x plus 3 times x plus 3 times x plus 3, and if we found, well, negative 3, negative 3, negative 3, negative 3, you see negative 3 is used 4 times. So multiplicity is simply how many times is a one value used as a 0, and again, the multiplicity matches the exponent of the factor that makes it 0. So let me do one more case in multiplicity real quickly. What would be the 0 here and what would be its multiplicity? Well, what would make x 0? Well, the only thing I could put in for x to make it 0 would be 0. And then what would be the multiplicity of that? That would be a multiplicity of 2. So this would be the 0, and it has a multiplicity of 2. Okay, so that's multiplicity, and that's linear factors, and that's how we're going to use those. So one of the things that you'll have to do is tell us what the zeros are and then make a quick sketch of the graph. Okay, so let's do that with these 4 problems. So the first thing we want to do is figure out the zeros because that's going to tell me where it's going to cross the x-axis. So here, a positive 1 will make this 0, so I know this is going to has a 0 at 1, and a negative 2 makes this 0, so I know it crosses at negative 2, so these 2 points are zeros of the function. Now this is a quadratic because there's 2 factors, and we know quadratics looks like parabolas, and it's positive, so I know it's going to look like this, something like that. That would be a quick sketch. Okay, over here, again, what are the zeros of the function? Well, a positive 2 would make that one 0, so I have a 0 at positive 2. And then I have a negative 9 here, that would make it 0, so that's a 0 as well. And again, we have a quadratic that opens up, so it's going to look something like that. Again, we're just making sketches, so that's fine. All right, so let's look at these last 2. Here we have 3 linear factors, so we're going to have 3 zeros. So what would make this one 0? Well, the number 0 would make that, so I have an x-intercept there. Negative 5 would make this one 0, so I have a 0 at negative 5. And at positive 8, I have a 0. So those are my 3 zeros. And cubics are going to look something like a curly Q looks something like that. Okay, so that should go through there. And then over here we have our last one here. So what makes this 0? That would be a negative 1, so that's a 0. A positive 1, so that's a 0. And a positive 2, that's a 0. And again, there's 3 of them. It's a cubic, so it's going to look like this. Okay, so knowing the linear factors gives us the ability to make a quick sketch of these. Okay, let's take a look at one other type of problem that you'll need to do, and then we'll wrap this lesson up. Another type of problem you'll have to do is this, where we give you the zeros and we'll ask you to write the polynomial in standard form that has these as its zeros. Now, if you think about what we've done so far, is we started with polynomials in standard forms. We've factored them into their linear factors, and then from those linear factors we determine what the zeros are. So in this case we're starting with the zeros, so what we'll want to do is to write the linear factors, and then we'll multiply those together to give us the polynomial in standard form. Now to write linear factors, here's what we do. We always take x and we put minus, and then in here we put the 0. So x minus the 0 gives me the linear factor. Okay, so this is how we're going to go from the zeros to write the linear factors, and then once we have the linear factors, you already know that we just multiply those together to get standard form. So I do x minus, and then I put in the 0, negative 2, and then an x minus, and I put in the 0. And then I x minus, and I put in the 0. So now I have my 3 factors, so I simply need to multiply them together. Now x minus 0 is just x, so I'm going to put that out in front. And then we have this. So then we can distribute this or this first, it doesn't matter. I'm going to distribute the x first. So this is going to be x squared plus 2x, and then that's going to give me then my answer, and then I need to multiply that times this. So distributing, I take the x squared times this whole thing, and then I take the positive 2x and I multiply it times this. Whoops, it's a minus. And I distribute those out and I'll get my polynomial. So this is going to be x cubed minus x squared plus 2x squared minus 2x. So I'm going to get x cubed plus x squared minus 2x. So this is the polynomial in standard form that has these 3 values as its 0. So remember, the only thing you'll need to remember here is once you have the zeros, you simply use x minus the 0 to get the linear factors, and then we know that we multiply the factors together to get the polynomial. Okay, so we'll do one more video where we take a look at some applications of this, and then we'll wrap up this lesson.